So hello everyone, today we'll be giving the LeetCode contest. I have already opened problem 4, so let's start from here. Okay, what do you say? Let's start from problem 4. So wait, am I getting recorded first of all? Yeah, I am getting recorded. Okay, you are given two integer arrays nums1 and nums0, each of size n. Nums1 of I represents the number of 1 in the ith segment, and what does nums of 0? Okay, number of zeros in the ith segment. For each index I construct a binary segment consisting of nums1 of I occurrences of ones followed by, you may rearrange order of these segments in any way. After rearranging, concatenate all the segments to form a single binary string. Return the maximum possible integer value of the concatenated binary string. Okay, so you basically need to find some sort of an optimal order to concatenate the binary strings to maximize the binary value, right? You want to maximize the binary value, isn't it? So you want to maximize it. You want so how can you maximize a binary number? The thing is, how can you maximize a binary number? Okay, there should be more number of ones. Okay, there should be more number of ones, like more ones at what do you say, MSB, more ones towards higher significant bit positions. Okay, and followed by zeros. This is what we'll do. This is how a binary number gets bigger, right? So somehow, since we can rearrange it, we need to make sure that we are placing the ones towards the most significant side. So each segment I is nums1 of I once followed by num0 of, so there would be this kind of structure, some number of ones, some number of zeros, isn't it? And the sorting rule for this, for two segments A and B, A should come before B if concatenation of AB as a binary number is greater than BA, isn't it? So we need to compare two things, AB and BA. This is what we need to do. Okay, this is what we should be doing. So okay, so I need to compare AB and BA. Should I actually convert them to some sort of a decimal numbers and then compare? Is that a good idea? I don't think so. Can we somehow compare in a different way? Let's move to some other problem. We'll think of how to compare them, but we are very close. I can say that we are very close. We just have to figure out how to compare them. But yeah, let's move to the first question. Why is this not getting clicked? Yeah, why is this not changing now? What just happened? Yeah, so yeah, you are given an integer timer representing the remaining time on a traffic signal. The signal follows rules. Timer equal to 0, signal becomes green. Timer equal to 30. The signal is orange, timer is, yeah, then the signal is red. So I just need to write some if else statements. If timer is equal to 0, I would return green. Okay, since you are using a return statement, no need to write an else if. if timer is equal to 30, return orange. If timer greater than 30 and timer is less than or equal to 90, I'm supposed to return what? Return red. Otherwise, I'm supposed to return invalid. Alright, so let's run this. Should be passing. I feel like submitting this now because it's taking so much time. 60 red, 5 is invalid, 5 is invalid. So yeah, it's working. So let's submit it. Okay, one done. Move to the next one. Today the contest feels slow. Even though I click stuff, it's not working. Count digit appearances. Now this thing. Is LeetCode glitching or what? Every time I should press this reset code button to get the template. You are given an integer array nums and an integer digit. Return the total number of times digit appears in the decimal representation of all elements in nums. Okay. Okay, so what are the constraints? Nums length is 1000. Nums length is 1000. And this thing is 10 power 6. So for each number, if I extract the digits, which is a simple program, I can do it, right? So I can just do int answer equal to 0. Num in nums while okay, wait, if num equal to 0 and digit equal to 0, in that case, okay, so answer would be plus plus and just continue from here. No need to check for the remaining, because while extracting the digits, the 0 appears at the base case, so it's a problem for us. Let's handle it before itself. So if n modulo 10 equal to digit, just do answer plus plus and n divided by equal to 10. Finally return answer. Hopefully this should work. Looking at the constraints last time, okay, this is num. Last time I messed up constraints. However, I also messed up some, I spoke some random stuff, so the video got into some trouble. Okay, keeping all that aside, for the next one should be 0. Done. Let's submit. Okay, second one done. Let's move to the third one. Okay, nums considered alternating prime if elements at even indices are prime numbers, elements at odd indices are non-prime numbers. In one operation, you may increment an element by 1. Return the minimum number of operations to transform nums into an alternating prime array. Okay, so forget about how to compute primes. We know many ways. We can do fast prime, or we can do the prime pre-compute, which is sieve of Eratosthenes. Okay, so I guess sieve would be perfect for this one, but that's a very basic thing. Okay, let's come up with the logic first. Let's come up with the logic first. So if it's an even index, nums of I is not prime, isn't it? Sorry, if it's an even index, nums of I is supposed to be prime, and if it's an odd index, nums of I isn't supposed to be prime. It's supposed to be a non-prime. So if nums of I is not prime, keep incrementing until you reach its nearest prime. Okay, until you hit the nearest prime, keep incrementing it. And coming to the odd index, we can do some good stuff, like we know that except 2 and 3, no two consecutive numbers are prime, right? So except for 2, if the number is greater than 2, if I simply add a plus 1, it would become a non-prime. So that's all I need to do. First thing I need to write the sieve. So let's write a bool is prime. What should be the size? Let's keep it. What should be the size? 10 power 5. 10 power 5 should be the size. So let's take it as. Is it 10 power 5? Let's take one more watts in this. Or let's take some random number. I always take 1500. So let's keep it this way itself. So let's write void sieve. Okay, let's take it a void sieve, and first let's fill is prime. Let's do it without this for end, or else wait, let's use fill itself. Is prime plus 1500. Let's fill this with true. Okay, let's fill this with true. Initially, let us assume all are prime. Oh, actually, we know what sieve, so I don't think I need to explain much about it. Okay, so these two things are not prime. Let's mark them false. P equal to 2. Is it better to do sieve? And are the dimensions right? They seem right to me. Constraints. Nums of I is this 10 power 5 or 10 power 6? Okay. Looks like I guess I need to change my spectacles. If it's a prime, okay, so the size would be 1004. Let's take it 1501. Okay, let's take it 1501. This should be 1500. Done. At the end, we have a pre-computation for the primes. Okay, so let's first call the pre-compute, and number of operations is, let's take initially 0. I less than 1 stop size. Okay, so while it's not a prime, while nums of I is not a prime, keep increasing nums of I plus plus, and also number of operations also would increase. Otherwise, while E is prime, nums of I, did I just write the wrong parentheses? Phew. Okay, while this is true, nums of I plus plus, also answer plus plus. Okay, isn't it? And at the end I need to return this answer. P is prime declared. Why did I add an underscore here? Done. Three 0 1. Done. Today most of the questions are like implementation question. I hope this passes. Done. Fourth could be a bit trickier. Okay, coming to the fourth one. Where did we stop this? We were like, okay, let's read the question again. I honestly missed the flow. Two integer arrays represents, fine. Construct a binary segment to rearrange. Done. So yeah, we were doing the sorting rule thing. We need to find a sorting rule, which we already found. You need to compare AB and BA. You are supposed to compare AB and BA. Okay, so how can we do this? How can we do this? How can we compare AB and BA? Is there any way? Is there any way in which you can do this? Because looking at the constraints, I don't think we can do something out of it. Okay, let's put that comparison thing aside. Let's put that comparison thing aside. How about just writing the logic? Can we compare just normally, like wait a minute, sorry, can we just compare it like Can we use some sort of ratios? I guess yes. Can we use some sort of ratios for this? Okay, let's keep comparing aside. Int n equal to, let's take nums 1 dot size, and let's store it this way: nums1 of I and nums0 of I. So now we have what was nums1 of I representing? Number of occurrences of 1, and nums0 of I represents number of occurrences of zeros. Now you are supposed to sort the segments. Now you are supposed to sort the segments, isn't it? But using some sort of a comparator, which we'll write much later. Let's take a long result is equal to 0, and let's declare a modulo here. 29 plus 7. I guess n is already used. Let's call it x. Int y would be equal to s dot second, or better call them o. Let's call them z, which is 1 and 0. So return result. This is the basic template idea. Okay, it's still an implementation question. We just need to figure out some sort of a logic for this. What did you do? You just took the pairs, structured them, sorted them, then you just iterated over them. Then we'll compute some few stuff which we'll look at it later. So coming to this, okay, looks like I need a board. So I guess am I complicating this? Like I just want to figure out. Okay, so we need to derive some sort of a formula to compare the binary segments to find the optimal order. of binary segments to maximum. That means we just need to compare this AB and BA, isn't it? We just need to compare this AB and BA. Okay, we need to form a criteria to compare this, isn't it? So when you when you not compare, when you concatenate two binary segments A and B, the order matters, right? The order obviously matters because the numbers are positional. So if you place a heavier binary string, heavier segment, uh, heavy in the sense with the one with the more significant bits, so it results in a much larger total value. So let a segment S have, let us take a segment, segment S has some n0 number of zeros, n1 number of ones. Let it have n0 number of zeros and n1 number of ones. So the length would be n0 plus n1, isn't it? And a value would be, what would be the value? What would be the value of this string? What would be the value of this binary string? It would be equal to 2 power number of ones, which is n1 minus 1, isn't it? Okay, so if there are, let's say, 4 ones followed by 2 zeros, that would mean this particular number has a value in decimal system. Its value would be equal to 2 power 4 minus 1, isn't it? And the value of n1s is this thing. When followed by n0 number of zeros, does that means till now we have computed the value of this 4 ones. If there are more zeros, it's basically like doing a what action is it? It's left shift, right? So you're just multiplying it by 2 power number of zeros, isn't it? You're multiplying it by 2 power number of zeros. So when you put a segment A before segment B, which is AB, the value of A is shifted to left by entire length of B, isn't it? So the total value is value of A multiplied by 2 into length of B plus value of B. So the comparison, okay, let me write this expression. First thing, there would be a value of A, which we are computing this way. This is the formula for V value of A multiplied by 2 power length of B, because that many extra numbers are coming here. If let's say this was the existing number, you are writing some more numbers here, does that simply mean you are still shifting it? You are shifting it again left. You are left shifting it again by 2 power LB. So the value of A into 2 power LB plus whatever the value of B is there, it's getting added. So can I say this? Can I say this is the value of AB? This is the formula for value of AB. And to compare value of AB and value of BA, how can I compare? I can do value of A into 2 length of B plus value of B, and I can compare this with value of B 2 into length of A plus value of A, isn't it? And if I have to compare this, let's say greater than, if I rearrange terms, if I take this value of A here, it would be VA into 2 power LB, which is length of B, minus 1 greater than BB 2 power LA, which is length of A, minus 1. Isn't this the expression which I get? So if I derive a fraction out of this, now this is reminding me of my JE days. I'm bad at maths. Actually worst at math. So VA by 2LA minus 1 and VB by 2LB minus 1. This is what I get after lots of solving expressions. This is what I get, right? And we already have the formula for VA and VB. So if I write this expression in terms of the formula, what do I get? If I simply write this expression in terms of the formula, so what do I get? The formula which I got was let me full screen this here. The formula which I got was VA divided by 2 power let's call it length of A minus 1 greater than VB divided by 2 power length of B minus 1, isn't it? Now I need to check the constraint because I need to make sure whether I should be using modular exponentiation or the bitwise operators for calculating 2 powers. So yeah, I should be using modular exponentiation for obvious reasons. So let's simply write a modular exponentiation code here. Let's write, okay, after the modulo declaration. Let's write it as PW, enough. And okay, now first let's write the comparator. Okay, how about writing a comparator first? So what was the expression again? Sorry for this. What was the expression? VA by 2LA. Actually, I wrote a comment here, right? Okay, wait. Okay, let's write this expression only, nothing else. So if I just write a comparator here, which would take I'm not gonna explain stuff again because I believe I'm explaining quite well, and most of the problems are just implementation, so it's not that great while explaining. 2 power BA was 2 power. Okay, A dot first plus A dot second, right? A dot second. This was it. A dot first. Wait a minute, what was the expression? I myself derived it. I'm only forgetting this. 2 power n1 minus 1. This was the expression for VA. Okay, so power of 2 A dot 2 comma A dot first. And this is to be multiplied with divided with power of 2.0 A dot first plus A dot second, A dot first plus A dot second, minus 1 now coming to VB, power of 2.0 B dot first, 2.0 B dot first, minus 1.0 divided by power of, and this whole thing should be now bracket B dot first minus 1.0. Okay, so power of 2.0 B dot first plus B dot second minus 1.0, isn't it? Are we doing this right? I feel some parentheses are missing or some sort of issue like that. We have power 2.0 A dot first. Let's end this here itself. Okay, this thing ended here, and this whole thing is divided by this thing. So yeah, done. Same for this thing. Semicolon here. No need of this, I guess. Yeah, done. Looks good. Let's now I just need to make sure VA is greater than VB. This is how I am comparing while sorting this. Coming to this thing, we need to figure out some logic, right? So let's take long P equal to 2 power number of ones, and result would be equal to result multiplied by P plus mod mod. This is the expression we derived, right? Sorry. Okay, isn't this the expression which we derived? This is right. Done. Looks good. Let's try to run this. S was not declared. This isn't S, it's segment. Mod, what was the function name? PW. $50. Why is it printing 50? Till comparing part it seems pretty right, isn't it? Till comparing part it seems pretty right. Is it giving at least one right answer? 226.50. What is this? Where did we mess up? See, modular exponentiation doesn't seem anything wrong here. 1e9 plus 7 is the mod which was given. If it's odd, this thing is right, obviously. I don't think I can mess up modular exponentiation. Or maybe I can. Better write, and this also result modular mod. Not for this particular test cases, but it may fail somewhere. Coming to this, int n equal to nums1 dot size and a vector parent int nums1 of I, nums0 of I, segment of I, yes. Then we are sorting the segments. How are we sorting the segments? We are taking pair int A and pair int B, and we are taking a double value of A, which is 2 power A dot first minus 1 divided by 2 power A dot first plus A dot second, which is nothing but the length of A minus 1, which is the expression we just derived here. We derived it here. Now what's the issue here? Two power A dot first. 2 power A dot first minus 1.0. 2 power B dot first minus 1.0. And B dot first plus B dot second minus 1.0. Return VA greater than VB. Comparator also seems right. Result is equal to 0, and we have taken the segments. O is the segments first, number of ones. Z is the number of zeros. p equal to p is equal to 2 power 0, sorry, 2 power number of ones, result equal to result into p modulo mod, this is right, result plus p minus 1 plus mod modulo mod, result into, okay, sorry for this, should be number of zeros, right? We are supposed to multiply this with number of zeros. Now let's check. 120, 14, done. Let's submit. Okay, could this be an issue here? Pass 92 test cases. If 92 are passing, there's nothing, like, it's not supposed to give some sort of wrong answers. Somewhere the modulo is missing. Could that be a reason? Or it could be due to doubles floating point exception. Could this be due to doubles floating point exception? Am I getting recorded? And is my hair okay? Yeah. Sometimes I just ruin my hair. At this point of time, it feels pretty boring. Like after doing this much, after getting this much close, if the question is not getting solved, yeah, maybe a floating point precision error. Should we use some sort of unordered map for this? Can we do that? Yeah. Instead of storing it in a double, I guess it would be better if we store it in some sort of a data structure like an unordered map or something to avoid the floating point exception. I already ruined a contest of mine on AdCoder, I guess, because of the same similar mistake. This isn't first time that I'm doing this mistake. Okay, expression A first, A second, B second, B first, yeah, B first, plus b second, b first plus b second, comma a second, sorry, b dot first plus b dot second, b dot first plus b dot second plus a dot second, a dot first plus a dot second, and now I just need to sort this expression a. In reverse order. Also expression b, okay, that's it, and the rest of the things aren't supposed to change. Hope this also works. What am I typing? What am I even typing? Done. 14, 120, yeah. This is just the powers represented in terms of data structure, and okay, time limit exceeded. Just one test case. Look at this. Look at this. Just one test case to go. I feel like writing an if statement for this one test case. How can it fail for just one test case? Where else can we optimize this? What if we just put some fast IO or something like that? I think there's something for fast IO here in LeetCode. Some auto init thing. I forgot the syntax. Should I Google this? Or else search for a better optimization? The optimization, whatever it's there, it's supposed to be inside this thing only, because you see there's no other way. Like anyways you have to iterate over the segments, right? And anyways you have to store them. So this thing is not a problem. Neither is this thing. All of this is just n log n, and even this is n log n, but I don't know why is this not passing. I feel like I should do that fast IO thing once. Fast IO for LeetCode. Fast IO for LeetCode. Fast IO for LeetCode. But how can I use it in LeetCode? Can we optimize somewhere which we are missing out? 555 out of 556 is the worst situation. I don't think there's. However, the modular exponentiation is also in logs. We'll try once with fast IO, then once we'll try with the other thing. Okay, let's try the fast IO first. Let's write it as a static method. Is this how we are supposed to write it? I've written this once, I remember. Sync studio false. I don't even know it would work or not because LeetCode's backend is highly optimized. Fast IO with deduced type constant requires an initializer. What if we write it inside the class itself? Okay, we have come very close. I have zero faith that this would work, and we are running out of time. So this is a really bad situation to be in. I'll try my best to make it till all kill, but I'm not sure. I guess today I'll miss the all kill. Okay, let's remove this. I don't need it anymore. What just happened? Let's leave this some random thing. So okay, so the basic thing which is giving you a TLE is sorting, right? The sort function. How can I optimize that one? How can I optimize that one? It's taking n log n time. We come we're comparing exponentials. Wait a minute, why are we like uh, we just need to compare three components, so why are we writing the whole sorting thing? However, it's more optimized, but yeah, still, can't we just do it without the sorting? And instead of vectors, can we use instead of vectors, what if we use normal arrays, like normal C arrays of size 3, and this is also of size 3. It requires some micro optimizations. I I can't really figure out why is it not passing that one test case. Is it that bad? D dot second. Let's call it SRT sort. Will do. It would take some star p. We just have 20 minutes left. Done. The idea still remains the same. We are just changing the way we were implementing it before. The previous one was also supposed to work. I'm not sure even this would work or not, but still. Okay, so let's check this out. $14, $120, and submit. So yeah, that's it. I hope this proof was clear. I hope this proof was clear. That's the core thing here. I don't know why that old sorting approach didn't work. It's just sorting the powers. So yeah, that's it for today, guys. Thank you.